Hello out there, Physics 277 students or any other YouTube viewers who may be watching this video. Today we're going to continue our series of videos on the Linux command line interface with this video, video 10, where we'll be talking about wildcards, or what is known as globbing. Now, what is the motivation for why we would want to use this? Well, let's consider the fact that maybe we have a group of files that have something in common with one another in regard to their file names. Let me show you an example. In the shell window that I have open here in my current directory, if I do an ls, you can see I have quite a few files. And you can see these files have patterns in their names. For example, I have a bunch of files here, lect1.txt through lect7.txt. Their file names look very similar to one another. They're differing in this case by a single character, which is 1 to 7. Or I have a bunch of files here that have lecture notes in them, lecture1.pdf right here, all the way up through lecture15.pdf here. These share common attributes as well. They all begin with the word lecture. They end with the character string PDF. They have presumably some commonality about them. There are other examples I could look here. Maybe there's a pattern in the number in the name of this. For example, I have results 001.dat here, running up through results 013.dat here. If we wish to manipulate these files as a group, is there a way to do that? And the answer is yes. The bash shell provides us with a mechanism for doing that through the use of what we call wildcards, or file globbing, or globbing. It's usually referred to by most people as wildcards, but the technical term for it is file globbing or globbing, although very few people know that. So let's talk about how this works. Suppose we wanted to list a certain subset of these files. Suppose I wanted to list all the files that begin with results and end with .dat. Is there a way to do that? And the answer is yes. There are a number of ways we could do it. Let's start off with something fairly simple. There are going to be two characters that the shell uses as, quote, wildcards. What do we mean by that? Well, if you've ever played a card game where you had a wildcard in it, a wildcard is a card that, if you get it, can be used in place of any other card. And the same thing is going to apply here. There's going to be a symbol, or actually two symbols, that we'll use in the shell that will be, if they appear in a file name, as it appears as an argument on the command line, the shell will substitute for them so as to match a character or characters of any sort. All right? Those two symbols that we're going to consider here first are the question mark, which can be used to match a single character in a file name as long as it is a non-null character, meaning that it has to be a character. It can't just be no character at all. There's also going to be the asterisk here, or the star, which is going to be used to match a series of characters that can be of any length. And in fact, in this case, it can match no characters whatsoever. You might say, why would you want to match no characters? But that turns out to be somewhat useful for a variety of ways that we will see. So let's start with just a question mark wildcard. And let's see how that can be used here. All right. Again, it can match a single character as long as that character is non-null, meaning it has to be a character. It can't just be no character at all. All right. Let's look at an example. If I type the ls command and I give it a file name, let's say lecture1.pdf, ls, when we have that file name as an argument, just returns information about that file. In this case, it returns the name. All right. Let's now use a wildcard and see what will happen. If I substitute here and type, instead of lecture1, lecture question mark .pdf, that question mark right there before my, or right where my cursor is right now, will match any character in that position in the file name. So when I do that, look at the result I get. I see lecture1.pdf, lecture2.pdf, lecture3.pdf, all the way up to lecture9.pdf. So this is a mechanism whereby I can use a wildcard in a file name. In this case, it's the question mark that appears right here to match a whole series of file names. Now, how would that be useful? So, for example, I could use it with something like the cp command. I could say cp lecture question mark .pdf and copy it into a subdirectory. Let's say subdir1. Okay, and when I do that, I've copied that entire series of files, lecture 1 through lecture 9.pdf, into the directory subdir1. I can prove that to you. I'll do an ls subdir1, and you'll see they'll all be there now. There they are, in addition to other files that happen to be there already. So that's a very useful thing to do. So that question mark can be used to match a single character. Now, it will have limits to it. All right, so for example, if I try to do something like this, let's say, let's do an ls. Let me see what other files I have sitting here. All right. Okay, I have, lecture 11.pdf here. All right, let's do ls lecture 1 question mark .pdf. All right, in this case, this matches the file names that have the string of characters, lecture 1, followed by a single character, meaning that lecture 10.pdf, lecture 11.pdf, lecture 12.pdf, lecture 14.pdf, and lecture 15.pdf here are all matched by that. But what it did not match was lecture 1.pdf. Why? Because this pattern that I have here, where I use the question mark right here, had to match a non-null character, meaning it couldn't match nothing whatsoever. So that meant I didn't match, for example, lecture 1.pdf. So, is there a way we could match anything that had lecture 1 in it, regardless of what its length was? And the answer is yes. The other symbol that we'll use to match things, the other wild card, is the asterisk. And the asterisk can match any series of characters of length running 0 through however long you want here, and it can match virtually any character. So let's, for comparison purposes, substitute an asterisk here. We'll match lecture 1 asterisk.pdf. Let's see what we get. In this case, we got lecture 10, lecture 11, lecture 12, lecture 14, lecture 15, but this time we also got lecture 1.pdf, and that's because the asterisk can match a null character, meaning no character whatsoever. So this is useful in a way. On the other hand, if I wanted to manipulate files and basically only wanted to copy things like lecture 10 through lecture 15, it might be wise to actually use the question mark there as opposed to the asterisk. So we have two possible choices for the way that we can do things there. Now, both of these wildcards can be used at the beginning, middle, or end of a file name. And let me show you some examples of this. Let's say, okay, we matched already lecture star. Well, let's just take this out, the one. Lecture star.pdf matches all the files that begin with the word lecture and end with the character string .pdf. All right. I don't even have to put the dot in. I could just say lecture star PDF like this, and it would also match all of those things as well. All right. What if I use these at the beginning of a file name? Well, let's do ls star txt and see what this matches. This matches all my files that begin with anything but end with txt. I could have also chosen to say .txt, in which case I would have matched the things that end with .txt. Why would that matter? Suppose I had a file that was named xyztxt with no dot in it. All right, this would match that, whereas this command with a dot in it would not. It would match something that ended specifically in a .txt. Okay, we could also use this in the middle of a file name, as we've seen already, or at the end of a file name. Let's match lect star like this and see what we get. And we match everything that begins with lect and ends with virtually anything. In this case, I have lect1.txt. Over here, I have lecture3.pdf right there. Oops, I'm sorry. I wanted to highlight the U as well. Lecture And here it matched something with a ure3.pdf on the end of the file name. So I can use these things at the beginning, middle, and the end of a file name if I want. If I want to, I can use them in multiple places. Let me illustrate this. I can say *3* like this. This will match any file that has a 3 in it anywhere. All right. In which case, I've got several files here that have 3s in them. I also matched a subdirectory that had a 3 in its name here. There's nothing in that subdirectory right now, but it matched it. Okay, so that's very useful to know. It can go at the beginning, middle, or end of a file. What if we want to match a specific character? Not just a character in a specific position, but a specific character. Suppose I wanted to list files that had, let's say, began with lecture here. Let's say lecture 1, but instead of matching anything follow that, I wanted to match a specific character. Maybe I wanted to match, let's say, a 1, a 4, or a 5 in the next position. Is there a way I could do that? Yes, there is, through something called the list wildcards here, which I can create a list inside a pair of square brackets here of characters that I wish to match. All right, so let me show you how that works. I'll say ls lecture 1, put a left square bracket, and let's put 1, 4, 5 here, like this. All right, and then I'll match anything after that, or let's say I want to match the ones that end with .pdf. I could do that. When I do that, look at what I matched. I matched lecture 11.pdf, lecture 14.pdf, lecture 15.pdf. If I had changed this to 2, 3, 5 here, I would have matched, in this case, lecture 12, lecture 15.pdf, lecture 12.pdf, lecture 15.pdf. I didn't match lecture 13.pdf because there was no lecture 13.pdf. All right. So I can use square brackets to match specific characters. I can also match ranges of characters. I can put inside the square brackets alphabetic or numeric ranges, meaning that I can have numeric ranges that go 0 through 9, alphabetic ranges that go up to a, lowercase a through lowercase z, or uppercase a through uppercase z. And they're separated by dashes. And let me show you how this works. Let's take that last command here, but replace it by a range now. Let's say we'll go 0 to 7 here. After the string of characters lecture 1, the next character could be a 0 through a 7 here, and let's see what we match. And there, in this case, I match lecture 10, lecture 11, lecture 12, lecture 14, lecture 15.pdf. Let me change that to just show you if I go 0 through 3. In this case, I only match lecture 10, lecture 11, lecture 12. Or I could have changed this to go here, 4 through 9. In case I would have matched lecture 14.pdf and lecture 15.pdf. All right, so we can use that way. I can use alphabetic ranges here. Let's look at the files and let's see if we can find something. Oh, so I have a series of files here, program_a.cpp through program_z.cpp. All right, these are presumably C++ files for some program. In fact, they're empty here. I just created empty files, but let me show you how this works, just using this as an example. I could say, let's match ls program *_ and then put in, let's say, A through Z. This will match virtually everything. In this case, that begins, oh, I meant to type a dash there, lowercase a through lowercase z, and it will match all of those things that I had there listed, program_A, program_B, program_C. I didn't need the wildcard. I actually could have left that out. Sorry. I would have done it just as well. All right. And I could match any of those things, but let me restrict the range a little bit. Let's say I want to match F through Z. All right, program_F through Z.cpp. And indeed, it goes from program F, it matches program_F.cpp, program_G.cpp, program_H.cpp, all the way up through program_Z.cpp. Or I could choose to end it earlier. I could start at A, end it at H, and look what I get. I get program_A.cpp through program_H.cpp. Right? So we can use these lists of specific characters to match as a wildcard as well, which helps us put sort of a finer grain control on what file names we'll match during our file globbing process. Okay, now we can use this with any command that would basically involve file names as arguments. So you've seen me do it with ls, you've seen me do it with cp. I could also use it with mv and the rm commands. All right, but there's a danger lurking here. Let me illustrate that for you here. All right. Let's do an ls. Let's suppose I want to delete all the files that end with .txt. Let me type the following command. I'll say rm star.txt, star.txt, and I execute this. And I got some messages. I can't remove directories because they have some things in them, so I can't remove those easily with the rm command that way. But let me do an ls and let's see what's left. What? All my files are gone. What happened? I made a typo. And it's a deadly typo when used with wildcards. Let's look at what I had here. I meant to type rm star.txt, but my lazy thumb hit the space bar and inserted an extra space there. So what happened? When this command was interpreted by the shell, the wildcard here had a space after it. And remember, blank spaces are what the shell uses to delimit arguments. So the first argument to this rm command was just an asterisk. And what did that match? That matched everything. I inadvertently wiped out all of my files. So there's two lessons here. One, be very careful of the patterns that you're using when you use these wildcards. If you're in any doubt as to what they're going to match, use an innocuous command, like something like ls, which won't alter your files. So I could have said ls like this, and I would have said, oh my goodness, okay, this matches everything. I don't want to do that. All right. Second lesson, always alias your rm command to do rm space -i. That is the inquire option to rm. All right. If you haven't seen my video on aliasing, that's video 6. I'll put a link to it at the end of this video. Please watch it. See how to set an alias for your rm command. In this case, all I would have had to do was alias rm equal rm space -i in single quotes like this. Now, when I did the rm command and used the wildcard, it would have prompted me for each removal, giving me a chance to say no. All right. Doesn't necessarily mean you're not going to, in a fit of madness here, or basically carelessness, just not randomly reply yes. Third thing to do. All right, third important lesson to draw from this mistake, which I illustrated on purpose here for you, always keep a backup. All right, in this case, I have a backup. Let me copy in another directory that I had already prepared here, sdemo1. I'll just copy all of my files. I'll use a wildcard for that, and I'll copy them here. All right, and it did it. It didn't. Oh, let me do a recursive copy using the -r option. It will copy everything from all the subdirectories. Now I have all of my files back. Always keep a backup. That may be the most important lesson to this. All right, but be very careful using wildcards because it is possible to make a mistake that you cannot recover from, and I speak from experience, having learned the hard way through the School of Hard Knocks. Okay, now let me show you again. If I hadn't typed that command that I originally typed, now that I've set an alias, look what would have happened. When I executed this command, now it would have said, oh, prompt me, do I want to delete this? Yes. It ends with .txt. Yes, it ends with .txt. Yes, 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 yes. Oh, see, now I have the opportunity to say no. All right, and so on. I can answer no, or I can type Control-C to abort this command. All right, having that alias set literally would have saved my bacon here. All right, or my files, if I want to be literal. So, anyway, always make sure to do that. It's good practice to always alias your RM command. Watch video 6 if you haven't seen it about how to do that. Set it up so that it's in your .bashrc file, or if you're one of my Physics 277 students logging in on our math lab systems at Stony Brook, set it in your my.bashrc file, in your my SB files directory. In the video, I show you how to do that. So otherwise, this is all we're going to talk about this time. Watch for the links at the end of this video. If you like this video, please click like to let me know. If you have questions about it, please see me during office hours if you're one of my Physics 277 students, or you can post a comment that I'll respond to. And if you like these videos, please let me know. Click like, let me know, and click subscribe on my channel to get updates about future videos coming out. So, see you here next time.